Hello, my name is Stephen Gottlieb, and I made up the Calculus 2 video. At this point, I would just love for you to sit back and view a sample demonstration that I made up. That way you get to see a little bit of my teaching style. Going to solve an integral by using the technique known as by parts. And this here is the formula. In the video, the full video, actually show how you can easily derive this. That way, anytime you forget it, you can come back and figure it out. How about we use by parts to solve this integral? The integral of x times ln of x times dx. So this integral should be written like this. That is, part of this I'm going to call u, and part of it I'm going to call dv. So I'm going to call part u and part of it dv. Okay? Now, I need to know u and v. Well, if I call part of this u, I know u. But I don't know v. I know dv because I'm calling part of this dv. So I know dv, so I need to know v. That is, I'm going to have to integrate whatever I call dv. I'm going to have to be able to integrate it. And I also, so I know v because I integrated dv and I found v. I found it there, so I know it here. And I have to be able to find du. Well, if I know u, I have to be able to differentiate it to find du, or be able to find the differential of u to figure out what du is. Okay. Well, in my opinion, there's only two possible choices. I can call this u and that dv, or, remember, multiplication commutes. It's x times ln of x times dx. I can have ln of x times x dx. So maybe I call this u and that dv, or maybe I call this u and I call that dv. Now remember, I need to be able to differentiate u, or find a differential of u. I can differentiate x, which is good, but I really can't integrate ln of x dx to find v. Because I need v to multiply it by u. Remember, this integral is going to equal to u times v. I need to know what v is. In fact, the way you find the integral of ln of x dx is by parts. So this method did not work. That is, calling ux and dv ln of x dx didn't work. Okay, let's go here. If I let this be u, I have u, and I need du. Well, I can integrate ln of x or take the differential. They're very similar, taking a derivative and the differential. So I can find du. And if I call this v, I can integrate this. So that's the one we're going to use. I'm going to let u equal to ln of x. And I'm going to move this over a little bit. V and dv. Now, the derivative of ln of x is 1 over x. That is, the derivative of the left side is du dx. The derivative of the right side is 1 over x. But I don't want to know what du over dx is. I just want to know what du is. Well, no, it's kind of hand-waving, but it does get you your answer. Du, so I'm multiplying both sides by dx. 1 times dx is dx over x. Just bring the dx up here. The dx in the bottom here goes up there. So du is dx over x. And dv is x dx. Well, if I integrate this, I get v. If I integrate the right side, that's the simple one. get x squared over 2. Now sometimes it really matters what constant you add, but 9 out of 10 times or 99 out of 100 times, don't worry about the constant. Okay. So now that we have this, we're almost done. We're going to have to do one last integral, but that one should be easy. And if it isn't, either we didn't call the right things u and dv, or this is not a problem that should be done by parts. So the integral of x times ln of x times dx is equal to u times v, ln of x times that. I'll write v times u though. It's x squared ln of x over 2 minus the integral of v du. Why, that's v times du, which is dx over x. Okay, now before we go on, I just want to point out something. I said I was going to write v times u. And if you like to think of a 1 being under there, fine. Well, x squared times ln of x is just what I put on the top, and 2 times 1 is just what I put on the bottom. Okay, so let us solve this integral. So you have x squared ln of x over 2 minus, I'm going to bring the 2 out since it's in the bottom, say half. Put it in front of the integral, and x squared over x is just x dx. Okay, so we're almost there. X squared ln of x over 2 minus 1/2 times the integral of x to the 1 dx is x squared over 2. So, but basically, 1 times x squared is x squared, and 2 times 2 is 4. So you get x squared over 4. And since it's an integral, plus c. This completes the sample demonstration for my Calc 2 video. Hope you learned a little bit about integrating by parts. And thank you for viewing my video to the end. Most of all, I'd like to wish you great success with your Calculus 2 class. Thank you.